number 2 on here. And then we're going to move on. So hopefully this will help those of you who were not here on Friday. Right? So what we're doing, there are steps on the handout. It says steps to graphing in standard form. So that's back over here on the first page. So those are the steps. So we're going to identify A, B, and C. Then we're going to find the axis of symmetry using x equals negative b over 2a. Remember, the axis of symmetry is a line. Okay, wake up. And so you will then graph it as a dashed line. Okay, a dashed vertical line that goes through that point on the x-axis. Then we're going to start filling in our table, and we can use the table function to find a lot of the values that we need in order to graph it. All right. So let's go ahead and take a look at this one, okay? Take good notes. All right, raise your hand if you have questions as we go. So the very first thing, so what's the first thing according to those steps on the previous page? Identify A, B, and C. So let's do that. So what is A? 1. A is the number. Remember, A, B, and C are numbers. There's no X's, okay? 1, what is B? Negative 6. And C is 5, okay? Alright, positive 5. So we're going to find our axis of symmetry. So X is the opposite of B over 2 times A. So the opposite of a negative 6 is what, class? Positive 6, over 2, which is 3. So the axis of symmetry is X equals 3. Don't just write 3. You must write it correctly. Write it right, okay? There's no shortcuts. Alright? So now, how do I graph that again? How do I graph that? We're on the handout from Friday. The handout from Friday. How do I graph that? Look back at the steps on the previous page. Okay? Okay, it says right here, graph this lightly as a dashed vertical line. Alright, so that's what we're going to do. We're going to go to 3 on the x-axis, and we're going to draw a dashed vertical line. That's the axis of symmetry. Remember, the vertex is going to be on that line as well. That's why we use 3 and put that into the equation, because the vertex is going to have an x-coordinate of 3. Because it has to, it's on the axis of symmetry. Okay, so they have to have the same number. So we know the vertex is going to be 3 comma something. Alright, which is what I think Akiva was trying to tell us to do. So now, if I know the x-coordinate, which coordinate am I missing? The y. So I use x to find y exactly by plugging it back into the original equation. Some of you guys need to write little annotations on your paper so you can know what we're doing. Yes, sir. Yes, look on my desk. You can get one from me. Okay, so y equals 3 squared minus 6 times 3 plus 5. Did anybody already type it into the calculator? Okay, I got an answer. What you guys get? You got negative 4. Anybody else get negative 4? You need at least 2 people. Okay, got negative 4. Okay, so it equals negative 4. So what does negative 4 represent, class? The y coordinate of what? The vertex. Okay, and incidentally, the vertex in this case is going to be a max or a min. It's a min. How do we know that? Because A is positive, which means the parabola opens which way? Upward. Awesome. Okay, it's an upward opening parabola. Alright, so now I know my vertex is at 3, negative 4. So I know it's going to go up. But I can't draw the parabola. We have to get a little more information so we know, is this going to be a very wide parabola or a more narrow parabola, okay? And so let's get some more values. Now let's go ahead and do domain. The domain is always going to be the same thing, class. What is it? No? All real numbers. Look at the previous problem. The domain is all real numbers. Okay. Okay. Now, what variable or letter do we always start with to write the range? Always start with y, and then it's either going to be what symbol, or either greater than or less than. But because it's opening upward, what's going to be? Greater than. Okay. I just think upward, getting bigger, greater than. So y greater than, and then that always comes from the y coordinate of the vertex. So this is a y, this is a y, that's a y. So the vertex gives you two important pieces of information. The vertex tells you where you can find what? The x coordinate tells you where you can find what? What does the x coordinate of the vertex correspond with? It also corresponds with another piece of information we already found. The AOS, okay? So the x coordinate of the vertex is the AOS, tells us what the AOS is, and then the y coordinate of the vertex tells us what is. It tells us what the range is going to be, okay? Those are really important facts, okay? So what I just said, you need to find a way to write that down. All right. So then the zeros. So the zeros are the y, the x-intercept. So let's go ahead and plug this into the calculator. So everybody clear out what's already in there. Second plus 712. Second plus 712 will clear it. Okay. Type the equation in. Graph it. Okay, so now we're going to find. Okay. From the original one?
I think it's zero.
It's what zero? It just depends on what the x values are that we actually find a rate of change for. Okay? Alright. So, I know what you're thinking. Alright. So anyway, so let's go to the table. What is always going to be, okay, remember how on a previous problem, instead of zeros, it says x-intercepts? Why is that okay? They're interchangeable. Okay, remember those four interchangeable words? Zeros, x-intercepts, zeros and, roots and solutions. Okay, those are interchangeable. So this time they said zeros. It's the same as an x-intercept. So some of you might need to write x-intercept there. Okay, and the x-intercept is where y equals what? Zero. Okay, so that hopefully we can find that in our table. Do you remember how to get the table? Second and then graph. Okay, so the x-intercept is where y equals zero. Okay, I found them. Did you find yours? Find them? So you go to the table. Who needs help getting to the table? Second graph. What do you have? You type the equation in? Type the equation in now? Oh my God. Okay. All right. How many people have found the zeros in your table? Nobody? Okay. All right. How many people, answer this question, how many of y'all have typed this equation in for y equals?
Wait,
Okay, you have to type that in first.
I typed it in normally, I didn't type it in right.
Okay, well there's two zeros. There's two zeros. You have to find two spots where y equals not where x is zero, but y is zero.
You said where y is zero?
Yeah, but don't yell anything out first because everybody. Okay, hold on. Let's get everybody caught up. Okay. How many people need more time to get the equation typed in? Okay. Okay, let's get the equation typed in. What's up, guys? When you type the equation in, you type this in. Okay, so x squared.
And then you press second.
Oh, here.
Okay, you're the second.
Who is that? Who's that? I don't understand.
I understand.
I don't.
Okay.
Get it?
Okay. Now,
I didn't know.
graph.
I'm already.
Okay. Second graph. This is the table. Okay.
Wait, y equals 0?
Wait a minute, is this not recording? Yeah, it's recording. Okay. All right. So now, so where do we look in the table to find the x-intercepts or the zeros? What column we're going to look in first? The y column. And what number are we looking for in the y column? We're looking for 0 in the y column, okay, to get the x-intercepts, because the x-intercepts occur where y equals 0. Now we're going to flip. Now we want the y-intercept, so that's where x equals 0, and which is what a lot of you found initially. So where x is 0, what is the y value? Anybody? Go. Anybody? 5. Is that what you got, Tommy? What's the order pair, Tommy? 0, 5. Okay? 0, 5. So x is 0 for the y-intercept. Y is 0 for the x-intercept. Okay? All right. So now, guys, listen carefully. Okay? Listen carefully. Now we can start plotting some things, and so we can graph it. Once we have these intercepts, that's usually enough information to draw a reasonable estimate of the graph. Okay? So I've got zeros. I've got a point at 1, 0. Okay, and I've got one at 5, 0, and then I've got one at 0, 5. So I know my vertex is way down here. Oh, and if there's a point on the left side, we know that there's a mirror image where? On the right-hand side. So how far is this point away from my axis of symmetry? How many units? 3 units across. I'm glad that made you happy. Okay, so 1, 2, 3. That means there's 1 over here. Okay, so now I can draw my parabola. Hopefully yours is a little clearer than mine. Okay, and make sure this is curved and not a V at the bottom. Don't make that a sharp point. It needs to be curvy. Okay? Alright? Alright, so that's your parabola. Alright? So once you find your zeros and your y-intercept, then you should have about 5 points to graph, and that's more than enough to draw a reasonable sketch of your parabola. Okay? So now let's do this other stuff. So interval of increase. What are the words that I told you to think of for increase and decrease? Increase is the same as saying what? Rising. Okay? So that's rising, and decrease is falling. Okay? What divides the parabola into a rising and a falling side? The AOS, okay? So we're looking on either side of the AOS, which is at 3. So I know it's going to start with an X, okay? I know it's going to have a 3 in it, but I have to figure out what these inequalities are. Okay, what is this side doing? Is it rising or falling? It's falling, because if you were walking down there and you hit this, you're going to go down, okay? So this side is falling. Okay, falling is the same as decrease, so this side is rising. Erase, so it can be rising. Okay, so now, if I'm on the left-hand side of the axis of symmetry, it's always going to be less than. Left-hand side, less than. Right-hand side, greater than. Okay, X, remember, X comes from this X right here, and that X right there. That's the axis of symmetry. so what's happening on the left side of the axis of symmetry is falling. Okay, so that means the decrease is here, and the increase is here. All right, so if I label this here, that tells me where to write what. Okay, I wouldn't put the falling side for increase. I wouldn't put the rising side for decrease. That doesn't make sense. Okay, so it's falling on the left-hand side of the axis of symmetry. Everything to the left of the axis of symmetry is less than 3. The numbers, the x values, are less than 3. These x values to the right of the axis of symmetry are greater than 3. And then finally, I'm just going to do one of these. We have to do the rate of change. What's one word that means the same thing as rate of change? Okay, it begins with an S. I think I heard someone about slope. Okay, so remember, we're looking for slope. That equals, so that's slope. And that's m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay? So once again, we use our table. This calculator is amazing. It's going to help you do so much if you know how to utilize the tool in your hand or on your desk. Okay? So if this is an x right here, that means that these two numbers are also x's. Okay? Did you hear me? Did you see? Did you see? If that's an x, remember that's telling you that these are x's. So they gave me my two x's. I'm going to use the table and find those x's and get the corresponding y values to put into my formula. So I know I've got one x is 0, so turn the calculator back on. Oh, okay, when x is 0, y is 5. And when x is 2, what is y? Wow. Negative 3. Where did she get that answer from? From the table in the calculator. Okay? Yeah, let us know. Don't just go along. Don't just go with the flow. This is not that type of thing. Okay? You've got to stop us. Yes.
So you have that large one over there.
I haven't done it yet.
So what do you think?
Where did I get this or this? Where did I get these numbers? Okay. We were given the 0 and the 2 right here. And then I looked for those corresponding y values in my table. So my first x is 0, my second x is 2. So what y value goes with 0 according to the table? 5. And what y value goes with 2 according to the table? Negative 3. Oh, and now I put them in the formula. Okay? So M.
We're going to like with the x, like with the x's, or
yeah.
Going to be like with the
no. Because you can't find it with the y. You have to have the x's. Okay? So m is going to equal, so I'm going to do negative 3 minus 5 over 2 minus 0. That gives me negative 8 over 2, which is negative 4. Okay? And then you do this one. Negative 3. I got negative 4. What's negative 3? Oh, you're telling me the numbers to the table?
Yeah.
Oh, my bad. I'll save that for you. I won't steal that joy from you. I'll let you do that later. Okay, you're so welcome. I knew Chris would appreciate that. You said, Akiva, you are welcome as well. Okay, I knew you'd appreciate that as well. Okay, so number 3 is yours. I'm in, so that's for you to practice. Yes. I don't know that will be everything in here. Oh my God. But I calculate it right out.
Yeah, that's good. That's good.
Next sheet. So this is called transformations of vertex form. So we've been looking at standard form, but there are other forms, and this is called the vertex form. And I love the vertex form because of its name. Its name is so telling. All right. The vertex form gives us the vertex of the parabola. That is so useful because it saves us time, okay? All right, Chris? So, let's focus on this. All right, I'll talk about Christian, I'm sorry. All right, you good. All right, so. All right, so check this out. It says that f of x, and by the way, f of x is interchangeable with what? With y, okay? So if you didn't know that or you forgot that, you should write that down. Sir? Vice versa. It works both ways, okay? All right. Okay, tomatoes, tomatoes. All right. So now, take a look at this form. You have some new letters. You're used to A, B, and C. Now, the A here is the same as the A from standard form. And that's going to come into play later because I'm going to show you a quick, easy way to change from standard form to vertex form, okay? Probably not today, though. So anyway, so A, that again tells us if our parabola is going to open upward or downward, okay? It also tells us if it's going to get more narrow or if it's getting wider, a compression or, a shrink, a stretch or a compression. All right. Now, H and K are so important. So the vertex is your H and K. All right. So the vertex is your H and K. And what that does is H comma K. All right. It tells us if the vertex is moving from 0, 0. If there's some type of transformation, a shift, okay? And so it's going to tell us if it's moving, if H is positive, that means, it sounds crazy, but it's going to be moving to the left because we go the opposite direction, okay? But if H is negative, we're going to go to the right, okay? And all of this is on your handout. You should be underlining this stuff as I'm talking about it. K tells us if it moves up or down. If K is positive, it moves up. If K is negative, it moves down. I like to say inside, I'm going to write a little note here. Inside, opposite. Outside, the same. So right now, some of you are missing a few little nuances because you get distracted easily by your classmates. This is very important, okay? So let's recap this. What does A do? It tells us if it's a reflection. Saying that it's a reflection is the same as saying it opens up or down. So if it was open upward, the parent function opens up. If it's being reflected, that means it's going to be opening down. That's a reflection, okay? If A is greater than 1, that's a vertical stretch. It's getting skinnier. If A is between 0 and 1, in other words, it's a positive fraction or decimal between 0 and 1, that means that it's a shrink, but I like to call that a compression, which is what it's also commonly called. So you might want to write compression here next to where they wrote vertical shrink. It means the same thing. Once again, what does H do? Okay, just remember, if it's inside the parentheses, it's going to do the opposite of that sign right here. Okay, so if this is if H ends up being, if this is a minus H, it's going to move to the right. If it's plus H, it's going to move to the left. The K, it is what it is. If it's positive, it moves up. If it's negative, it moves down. So this is inside the parentheses, it does the opposite. Outside the parentheses, it does the same thing, all right? Whatever the sign is, it does, If you feel like you can miss right now, this is new stuff, all right? Now, so all we're going to do real quickly is we're just going to talk about some transformations, okay? Yes?
We're getting close to time.
Thank you. Okay? All right. You guys are interrupting me, okay? He said it once, I didn't need it to be reiterated, okay? Thank you. All right, so let's look at all these things. We have x minus 3 squared plus 5. Let's have everyone's attention. So this is a negative 3. So which way is it shifting, left or right?
Oh, right.
It's going right 3. And plus 5 means it's doing what? Up 5. Okay, very good. What does a negative in front of parentheses mean? That's your A.
It should be,
Look back here. Okay, what does A do? If A is negative, it's a reflection. Okay, reflection means it's opening which way?
Oh, well, I don't know, downward.
Okay, it's going to open downward. Okay, -2 tells us it's moving which way? Right, 2. Does everybody see where you're getting those answers from?
Yeah.
Okay, is there a no?
No.
Okay, if this is negative, it moves right.
Oh,
Okay, and then
on number 1.
it doesn't mean it doesn't do anything. Oh, right 3 up 5. That's a -3, so it's going right 3. Positive 5 is going up 5. Okay, and this is going up 7. All right. All right. What about this? Try 3 and 4 real quickly. Don't say anything out loud. Write on your paper. Okay, let's listen quietly. I'm going to call on some individuals. All right. Hey, Aaron, for number 3, excuse me, students, please give me your attention. So for number 3, can you tell me what the 1/3, is that A, H, or K?
It's A.
Do you agree that it's A? Okay, it is. It's 1/3, so is that going to be...
Can you let Aaron?
Aaron.
Got her name wrong.
All right. So 1/3, is that bigger than 1, or is it between 0 and 1? Okay. 1/3? 1/3 is not bigger than 1. Okay, I said, is it bigger than 1, or is it between 0 and 1? Okay, so it's going to be a shrink because it's between 0 and 1. So 1/3 means it's a shrink. Okay? Aubrey, I'm coming to you, so I want you're going to do the next one. Okay? Jason, the +3, which way does it shift, left or right? So that's your 8. Okay, it's going to be left 3. Quiet, please. All right, Aubrey, the -2, is it going to go up or down? Down 2. Great. All right, let's look at number 4. Okay, Tommy, the 4. What does that tell us? Okay, very good. It's a vertical stretch. Abby, the -3. What does that tell us?
Go right.
Right 3. And Lauren, what does the +8 tell us?
8.
Absolutely. Okay, very good.
You're
Okay.
doing good.
Okay, now, listen carefully. So what we're doing on the bottom of this page is we're going to find some information based on the graph. So let's see if we can figure it out. Now, A is, that's that distance 1 unit away from the vertex, okay? It's like a slope, 1 unit away from the vertex. So let's see if we can figure it out. So what is the vertex? Here's the vertex right here. The vertex is an ordered pair, 2 points. -2. -2, 1. Okay, I hear some other people talking. Right now, everyone should be watching this. Okay? So, if you have the graph of a parabola, you can figure a lot of things out. Okay? So, A gives us, A is the slope, 1 unit away from the vertex. Everyone should be looking this way. Okay? Right? So, A is the slope, 1 unit away from the vertex. So what I'm going to do is I'm just going to go, I want to end up 1 unit over. So I would have to go up 1 over 1 to get there. So A is 1. Okay, or down 1 over 1. So in order to get to this point right here, I would have to go down 1 over 1, okay? So that's going to be -1. And that makes sense because the parabola opens downward. So this number has to be negative, all right? H, okay? So our H is 2 and our K is 1, okay? It's the opposite. So remember, when we're dealing with H, we're always dealing with the opposite. So if I were to write the equation for this parabola, it would be f of x equals -1 times x plus 2 plus 1. Now remember, to get to the vertex, I have to take the opposite of this. The vertex of this is -2, 1. That's what the vertex is. But in order to get a -2, this has to be a +2. All right? It's a how? Okay, be more specific. How to get what? Okay, so, and I get that so hard. I'll do another one. Okay, so to get the A, I need to get to a point on the parabola that's 1 unit either to the left or to the right of the vertex. So in order to get to that point will be right here, because this is 1 unit away. The vertex is, the axis of symmetry is at -2, and so I need to get 1 unit to the left or to the right. So I'm going to get to this point right here. So I'm just going to go down and over. So because I went down 1 over 1, which is -1. So that's why A is -1. We have to do a couple more for it to click, okay? H is going to be the opposite. So the vertex is at -2, 1. H is going to be the opposite of that. So it's going to be +2. K is going to be 1. And then I can put it in here. Let's just try another one. It's different, okay? So I'm trying to get to a point on the parabola that's 1 unit away from the vertex. So 1 unit to the left or to the right. So if I go 1 unit over and up, I'm right there, okay? So that's going to be 1 over 1. So A is 1. You're just going to have to do a lot of these to practice. Okay? Now, H, well, the vertex is at 4, -4, right?
Yes.
All right. So H is going to be the opposite of that. So H is -4, and K is also -4. But when I put it back into the vertex form, it's going to be, well, it's not going to be negative. It's going to be +1, which I don't even have to write the 1, technically. X -4. Oh, I left my square off here. Make sure you put the square here. Okay, -4. Okay. And just always go back and check. No, because when I take the opposite, I will get the +4.
Okay.
Okay, so what I'm writing here and here is what it's going to be. Okay, thank you. All right. Okay. All right. All right. Listen carefully. All right. So let's just try one more, and then we'll pick up the calculators. Okay. Listen carefully. All right. So for number 7, turn the page. Okay. So my parabola's open upward, so I know A is going to be positive. Okay. Are we on page, looking at number 7? Okay. So to get the A, it's the slope 1 unit away from the vertex. Okay. So if I to get 1 unit away from the vertex, I will just have to go up 1 over 1 to get to that point right there. Okay. So it's 1. Okay? Now, my vertex is at -5, -3. Okay? So I have to take the opposite of that number when I'm putting it back in. So because remember, if you look at the formula, there's a negative sign right here. Okay? So maybe it will be easier if I wrote it like this. I'll have to show you that way tomorrow. Maybe that'll be a little bit easier. But h is going to be 5. The k is going to be -3. Think about it this way. If I put x minus a -5, that gives you a +5. All right? So I think I'm just confusing you anymore.
Yeah.
Okay. So let's do that like that. Okay? Because this is going to be x, okay, plus 5 squared minus 3. Just remember, when you take the opposite of this, it should give you your x-coordinate of your vertex. So if the x-coordinate of my vertex is negative, when I put it here, it's got to be the opposite. All right? Okay. Let's take the third person in each row to use software for the calculator. Third person. All right. Let me go ahead and start this.